Okay, so today we're going to be talking about dilations. We are not going to do this notes page. The reason is you have 5 different pages over dilations that you're going to be doing, and I want to do an example, at least one on each page with you to help you get started. So rather than doing this, we're going to be covering all of this on the other pages. So let's start on page 10, where we have types of dilations. Dilations are either an enlargement or a reduction, okay? So something getting bigger or something getting smaller. Now, it's important to notice, if we look at these images, whenever we have a dilation, the images are similar, meaning their angle measures are the exact same, but their side lengths are not the same, but they are proportional. So we're not dealing with two congruent shapes where everything is the same. Our angles are the same. Our side lengths are proportional to one another. All right, so if I'm looking up here, if I have a scale factor that is greater than 1, so my scale factor is greater than 1, like this one is, where it's 2, this would be an enlargement. Okay, if we have a scale factor that is less than 1, like this one is, 1/8, that would be a reduction. Okay, so this is an example of an enlargement. This is an example of a reduction. Now you might ask, well, what if the scale factor is equal to 1? Well, then our shape wouldn't be dilated, right? Okay, so looking down here at part B, it says figure A is a dilated image of figure B. Identify the type of dilation, reduction, or enlargement. So figure A is a dilated image of figure B. So I'm going to highlight figure A. All right, so here's figure A. Remember, A is a dilated image of B. So how am I going from B to A here? It is growing or enlarging, right? So this would be an enlargement because we're going from B to A, all right? You will do that for each one of these. Moving on to page 11. On page 11, you're identifying scale factor. Now, we talked about scale factor a little bit in our proportionality unit. This really does connect a lot because our shapes are proportional. They are similar figures, okay? And we did a lot of work with similar figures. What we're doing here is it says figure A is a dilated image of figure B. Find the scale factor. All right, so just like in the first one, B is our original, A is our dilated image. So I'm going to highlight A. A is the larger one here, okay, and we're starting with B. Now, the most helpful thing is to just identify 2 points that are similar to one another. And so I'm going to do this one here and this one here, so the far right corner points. The reason I'm going to work with those is because they're in the first quadrant, which is positive and positive, so it might make things a little bit easier for me. So the first point is B here, so I'm going to start at my origin, and I'm going to go over 1, 2, up 1. So it's 2, 1. And that is for B, all right? Now for A, I go over 1, 2, 3, 4, 5, 6, up 1, 2, 3. So my question is, how do I get from B to A? 2 times what? 2 times what is 6? Well, 2 times 3 is 6. 1 times what is 3? 1 times 3 is 3. So we just determined that our scale factor is 3. This makes sense because going from B to A it is growing in size. So that means our scale factor would be greater than 1. This is an enlargement. If we were going from A to B, it would be a reduction, and these would be reversed, right? Our scale factor wouldn't in fact be 3, it would be 1/3 in that case. All right? Let's move on to page 12. Page 12 here, we have dilated coordinates. So it says find the dilated coordinates with the given scale factor. All that we're doing here is, remember, when we're dilating something, we're multiplying by the scale factor. So all that I'm going to do here is I'm going to take my scale factor and I'm going to make 4 new ordered pairs using a scale factor of 2. So -5 times 2 is -10. -6 times 2 is -12. Looking at Q, -1 times 2 is -2. 2 times 2 is 4. Looking at R, 4 times 2 is 8. 4 times 2 is 8. And looking at S, 1 times 2 is 2. -3 times 2 is -6. So that's all that I'm doing every time. I'm multiplying by the scale factor. Now I'm going to get you started on number 2 just because we might forget how to work with fractions. So if I'm multiplying by this scale factor, what I want y'all to do is I want you to take each number, and so I'll do 2 times 3, because remember it's like 2 over 1 times 3 over 2, which is my scale factor. Because if I made 2 a fraction, I just put it over 1. So I'd multiply across, so 2 times 3 is 6, and then I'm going to end up dividing by the denominator. 6 divided by 2 is 3. Okay, so you just multiply your numerators, divide by your denominator. So 2 times 3 is 6, divided by 2 is 3. 6 times 3 is 18, divided by 2 is 9. 8 times 3, etc. All right? Moving on to page 13, it says find the dilated coordinates with the given scale factor. Also draw the dilated image. So what you're going to do here is I would off to the side, or you could even write it right above each one. You need to know what P is, Q is, R is, and S is before you can dilate them. So if I'm looking at P here, I'm going to go 1, 2, 3, 4 to the left and 2 down. So that's -4, -2. That's my original coordinate. Now I'm going to go to Q, 1 down 2. So 1, -2. Now I'm going to go to R, 1, 2, 3, 4 up 1, so 4, 1. And then I'm going to go to S, to the left 1, up 1, so -1, 1. Now that I have those original coordinates, I'm going to apply my scale factor of 2. All right, I'll do this in a different color. So I'm going to apply my scale factor of 2. So I multiply by 2. So I get -8, -4. 2, -4, 8, 2, and -2, 2. All that I did there was multiply each number by 2. Now I'm going to graph these new points. So -8, -4, -8, 1, 2, 3, 4. And remember, I'm going to put P prime because it's my dilated point. Q is 2, -4. 1, 2, 3, 4. Q prime, 8, 2, 8, 2, R prime, and then -2, 2, S prime. Now when I connect these dots, make sure you're neat, use a ruler if you need to. That there is my dilated image with a scale factor of 2. Okay. The last page here, I think you'll be fine doing this. All you're going to do is this space is for your original points, then you have your scale factor, then you have your dilated points. If you're going from points to dilated, you just multiply by the scale factor. If you're going from points to dilated and you need to determine the scale factor, you need to ask yourself, this times what is that? If you're going in reverse, you just do the inverse of multiplication, which is division. So 8 divided by 4. 8 divided by 4 is 2. So A, 2, comma, 12 divided by 4 is 3, etc. All right? And then you'll answer some questions at the bottom. If you have any questions, please let me know. And go ahead and get started.